Good afternoon, my name is Stanislav Danylenko and I want to present you research of digital analog conversion method for reproduction of mechanical oscillation did by me, Oleksander, Vechur, Mariya, Shirokopetleva from Kharkiv National University of Radio Electronics. The problem is there is a group of people around the world who have hearing problems and cannot receive sound information from the outside world in a usual way. It's not always possible to solve their problem with the help of hearing aids or other currently known tools. The related researches is about microwave auditory effect, piezoelectric effect and perception of sounds through the outer and inner ear, spectroanalysis with usage of window functions and Fourier transforms, sounds recognition system based on neural networks, and digital to analog conversion at microcontrollers. The purpose of the research is to investigate alternative way of transmitting sound by airflow generated by fans and recognized by humans by means of skin. To achieve this, we need to create a software-hardware complex for generating airflows with special digital to analog conversion and conduct experiments with humans and a software classification system. The criteria for evaluating the result of experiments is a level of successfully identified initial classes of sounds. The experiment will be done for the different sets of count of sound and duration of sound, and we set the threshold level of positive result to 75%. The general flow starts from the getting the data from the source. It can be microphone, it can be generated per oscillator, it can be recorded to the audio format file. Then we generate a stream of digital audio data. Then this stream is processed by the algorithm and transfer the processed data to the device with the fans. Then we apply the digital to analog conversion and produce airflows that interact with the human skin. Human know the scheme of fans location and the frequency ranges that matches for the fans, and can get this info from the airflows and identify the initial class of the sound. For the experiment we use a complex with 9 delta electronics fans. The algorithm contains both standard operation and self-developed operation. Let's take a deeper look into this. First, we use a standard library for getting audio stream. Then we calculate average value from the all channels at time point and apply Blackman window and Fourier transform. Then we apply smoothing over time frequency data and convert it to decibels in ranges from 0 to 245. Then we filter the data after Fourier transform and divide to the ranges. For each ranges corresponds to the particular fan. Then we find the most common value at this range and convert the value to the range from 0 to 9 and add the prefix of the fan. Then we send this data to the target device and extract the prefix of the fan and value. Then perform scaling and call the Arduino pulse width modulation function to reproduce the value and generate airflow by the fan. The steps of algorithm took place to different nodes. For example, all the calculations took place in the client. Client sent it by the HTTP to the server. Server's intermediate nodes establish a connection with the Arduino and send the processed data in a byte format to the Arduino. Arduino use standard PWM pulse width modulation function and pins to operate the fans speed rotation. The standard flow of usage is started from the client request. Then the data is processed in the client and sent to the server. Server sends this processed data to the Arduino, and Arduino using this pulse width modulation perform control of the fan speed. Then the Arduino returns the info about fan state. Then the server collects this info and sends logs about complex state to the client. client shows these logs for its user. The software part is developed using the next technologies. The hardware part looks like this. The user interface contains different elements. For example, for visualization, the processing like time domain data, frequency domain data, the generated process data in 2-dimension and 3-dimension view. Also show logs from the server, allow you to select the data source and perform connect and disconnect, play, pause, like main control functions. Let's move to the experiments. The computer experiments is classification based on decision tree and ID3 algorithm. The data was saved to CSV file during complex was working. Experiment was done for 5 classes of the sound. The training sample is 20 items for each class, totally 100 training items. An item represents a set of 415 numerical values in range from 0 to 9. The test sample consists of 5 items for each class, but we got 0% of successful classification is totally negative result. Let's move to the human experiment. First experiment is training. The purpose is to remember which fan corresponds to a specific frequency range. The number of participants is 5. The number of attempts at each step is 2. In this table you can see this plus shows the positive identification, the minus shows negative identification, and the most common value in this table and the experiment in total is 80% is a positive result, and we can move to the common human experiment, which was done for different count of sounds and class sounds and different duration of the sounds. And we can see the positive result is for set with 4 count classes and 5 seconds of duration, and above the positive results is also for the count of 5 sounds classes and duration of 2 seconds and 10 seconds. In this picture you can see that sounds is not similar in real life, such as weapon shows, trimmer, teapot, but after processing in our complex it can be quite similar and can produce the problem of identification by the human. The next step is to investigate the optimal size, power, number of fans and their location, the best human's body part in interact with, reducing the impact of external factors such as wind, usage at commercial segment, and effectiveness of work with military-themed sounds. The conclusions. An alternative method for the reproduction and transmission of sound waves but by means of air was investigated. Software-hardware complex was developed. Experiment with classification software system based on a decision tree and model and ID3 algorithm has negative result, but for this task it's necessary to use more sophisticated approaches. An experiment with humans has shown partial positive result. Producible sound can be identified for specific set of sounds, count and duration. A small demonstration with the sound of play tennis. And thanks for your attention.